Hello everyone, you are all welcome to lecture number 1249, and today's topic is very interesting chemistry, that is called chemistry of alicyclic compounds. So in organic chemistry, if we are going to know about the reactions of carbon, mainly there are two types of carbon. One is called aromatic carbon and the other one is called aliphatic carbon. So the chemistry of aliphatic carbon and the aromatic carbon, they are quite different. That's why the class of compounds where the ring is formed by aliphatic carbons is called alicyclic chemistry, and whatever compounds are synthesized or isolated which are having a ring of constituting aliphatic carbon are known as alicyclic compounds. So here, for example, Ali stands for aliphatic carbon, and then cyclic stands for a ring formation. So once the ring formation is done by only aliphatic carbons, they are alicyclic compounds. For example, the smallest ring is like this, where 3 carbon atoms are there, and this is the smallest ring. It is called cyclopropane. And if in case there are 4 carbon and a ring formation is there, it is called cyclobutane. And if there are 5 carbon, 1, 2, 3, 4 and 5, it is called cyclopentane. And the other one which is having 6 aliphatic carbon, it is called cyclohexane. So these are all aliphatic compounds. They are in cyclic form, and that is in the ring. And first one is made up of 3 aliphatic carbon, which is forming ring cycle, is called cyclopropane. The second one, where 4 aliphatic carbons are involved to form the ring, is called cyclobutane. And the third one, where 5 carbons are involved to form the ring or cycle, that is called cyclopentane. And the last one here, where 6 aliphatic carbons are involved to form the cycle or ring, is called cyclohexane. And when we are talking of alicyclic chemistry, alicyclic compound, all these rings, they have different behavior. But before going to discuss their exceptional behavior of a small ring, so in that exceptional behavior of a small ring, when I will be discussing later on, it means that what type of angle strain is there. That is called exceptional behavior of small ring. Then medium sizing, and then again the stability of big size ring. Big size ring, when I am talking, it's about 6 carbon, like cyclohexane, then cycloheptane, cyclooctanes, cyclonone, cyclodecane, like that. So that chemistry will be different, and there some stereochemistry and some conformational analysis involved. That I will be taking care one by one. So here let me come to This is aliphatic compounds where all the carbons are aliphatic. Now the question comes, the students must understand very clearly the difference between aliphatic and aromatic carbon. Why it is called aliphatic carbon? The other carbon, for example, if I am writing like this, it is your benzene and this is your benzene and it is aromatic, and this carbon which is involved is aromatic carbon, and here this carbon which is involved here is aliphatic carbon. So it's very clear, in picture it is shown that the two type of carbons, aromatic and aliphatic. So if we see here, in the case of aliphatic carbon, there is no any such type of look like double bond, but they are not pure double bond. These two are not pure double bond, because in this case, if it is double bond, means the bond angle should have been 120 degree, or if it is single bond, then bond angle of tetrahedral should have been 109.5 degree, but it is not 109.5, rather than it is 136 to 137 degree angle, and it is neither single bond nor double bond. So it shows that these pi electrons here in the case of aromatic, they are not in the form of double bond, rather they are delocalized. They are delocalized. And where delocalization will take place? Where there is conjugation. Conjugation is a must. Conjugation is a must. Conjugation means there are two type of double bonds, possibilities of double bond. In one case, there will be alternate double and single bond. Double bond, single bond, double bond, single bond. That alternate double and single bond is called conjugation. Second condition of double bond is that isolated double bond. One double bond is there, after that 2-3 single bond, then again one double bond, then again 2 single bond, and then again 3 double bond. So it means they are not alternate. That is called isolated double bond and single bond. So to have aromatic character, to have aromatic carbon, conjugation is a must. And the conjugation is taking place where there are pi electrons. This one is sigma bond, sigma electron, and once these pi electrons are there, that is called pi electrons, and these pi electrons are continuously delocalized, is moving, that gives resonating structure, resonance formation, and where such type of carbon is involved, that carbon is actually aromatic carbon. Now, so here, in the case of A carbon and there are B carbon, in the case of A compound, there is alternate double and single bond, double, single, double, single, double. So it means conjugation is there, and when there is conjugation, it will provide the electron to move from one carbon to other carbon. And in this way, there will be formation of electronic road. I call it electronic road. This is your electronic Electronic road is provided for electron to move or delocalized from carbon 1 to carbon 6. Electron can move because of conjugation. The electronic road is provided. But in the case of B, where the electron is here in carbon 1, electron 1, 2, 3, 4, 5, 6. So here it is not having any conjugation, so that electronic road is provided to move electron from carbon 1 to carbon 6, rather than electron is restricted to be sitting on carbon 1. There is no chance of movement of electron or delocalization of electron. If such condition of carbon is there, that carbon is called aliphatic carbon. And why it is important to understand, to know the aliphatic and aromatic carbon? Because there is a big difference in properties and the chemistry, stereochemistry. For example, I am just giving you one example. If suppose you have one like this is aliphatic, alicyclic, that is cyclohexane. The other one is aromatic. So one is aliphatic, other one is aromatic. This is called benzene. So both are having 6 carbon, both are in ring form. The only difference in the case of cyclohexane, there is no electronic road provided to move from carbon 1 to carbon 6. And in the case of benzene, the electronic road is provided for electron to move from carbon 1 to carbon 6 because of formation of conjugation, double, single, double bond, that provides electronic road. So in that case, for example, if any hydroxy group is attached, the same hydroxy group is attached in aliphatic cycle. Hydroxy group, functional group is same. The only difference is that one hydroxy group is linked to aliphatic carbon, aliphatic cycle, and the other one is linked to aromatic ring. So in that case, total chemistry is changed. This one will call phenol, and it is acidic. And this is called alcohol, that is your hexanol, and it is basic. The reason is that in the case of cyclohexanol, the bond breaking will take place from here, and it will release hydroxy ion. So hexanol will release hydroxy ion in solution, and any species of compound which is capable of releasing hydroxy ion in the solution will be basic, and any compound which is releasing H positive, means proton, in the solution will be acidic. So in this case, it is attached here. So what is happening? There is a resonance, so it will be a pi electron here, and this will go here and it will be released. So here in the case of phenol, proton is released. And this is the reason, and this is the beauty of organic chemistry, that same functional group, OH, once it is linked to aromatic system, it will behave as acid, and once it is linked to aliphatic cyclic ring, it will behave as a alcohol, and it will be basic. So here the displacement and delocalization of electron is playing very important role in determining the chemical and physical properties of different type of organic compounds. So with this I will stop here, and in the next lecture I am going to discuss the exceptional behavior of small rings and angle strain, and that angle strain how to calculate and how it is going to play the role in keeping the small ring, medium sizing or big sizing in stable form. Once again, thank you very much for watching the lecture.